I'm going to talk about Fluence, and concepts here and details here overlap a lot with some of other projects that were presented today, and also a little bit related to IPC and FVM. Maybe not a little bit. So Fluence, like what we do at Fluence is basically we call it decentralized serverless platform, and the best analogy the example and analogy we give always is Amazon Lambda. It's like a serverless, functions as a server. Think of this way, but like in fact it's a little bit more more flexible and not like one-on-one mapping. It's kind of we usually think of it. It consists of several things. It's developer platform and compute marketplace, and yeah. So and it's kind of tries to reflect the FaaS developer experience. So you know, in FaaS you have these functions, step functions, events, cron jobs, all of this, and we have some sort of analogy to all of it. So we run code in WASM, we have WASM runtime, we have, as analogy to step functions, we have Aqua, which is a distributed like DSL that allows you to run distributed algos. We have kind of bridge to HTTP as self-hosted gateways. We have periodic jobs execution, which nodes can run as analogy to cron jobs. Payments on chain, and developer experience that also kind of looks similar to FaaS. Yeah, that's just a screenshot of CLI. The several important things about that. So Fluence, like when you deploy your function or like your application on Fluence, deploy to network, in fact, you deploy to a subnet. And subnet is a group of nodes that basically have all the same function deployed to them, and they know about each other, and they can be kind of tied together with any custom algorithm, sort of network algorithm in Aqua, that expresses how they should work together. And they all run WASM, and basically like Aqua runs between them. That's important. And these algos could be potentially anything. Could be like MapReduce, consensus, load balancing, replication, any kind of multi-party computation. Here is the code, the piece of code from our MPC example. Basically, implementation of threshold signatures to sign transaction for Ethereum wallet. Using subnet and basically distributing shares of the key to different nodes in the subnet, then collecting shares and generating signature. So any kind of this stuff can be implemented, and it's all optional or flexible. It's basically like code. But by default, there is no consensus, nothing like that. So subnet is a group of nodes. Yeah, this is. I think it's too small, but that's kind of how Fluence nodes looks like inside. They have this Aqua VM that runs Aqua that basically allows to receive Aqua requests and send Aqua responses back. And it runs WebAssembly in workers. It has like some built-in services, and it has access to effectors, to basically external stuff. Every node can provide access to different effectors. By default, we ship it with curl and IPFS. So the code in WASM can do HTTP requests and get responses from HTTP, and also can read-write to IPFS. But potentially any effectors can be here, like any binary or external stuff. Important thing about Aqua is it's secure, sort of. Not everything of this implemented at the moment, but that's kind of the picture how it should be. So the data that being passed over the network is encrypted. Inputs, outputs, basically like functions that being called all CID'd for memorization, for caching, for like all these optimizations. Verification basically works the way that whenever you have the Aqua algorithm that says, like, I want to go to the first peer and call function there, then go to the second peer and call another function there. The second peer, when they receive the particle, the request, the data piece from the first peer, they would validate this data against the script that's supposed to be executed, and we'd validate the signature of the first peer and validate the signature of the initial user who initiated this request. So basically, like, we need to authenticate that request was done by the user that could do this request, was authorized to do this request. Then the first function call was done by the peer that was also authorized to do it, not by some random peer. We need to check. We need to validate that this peer that executed the first function call, like, it was asked to execute the first function call. So there was a script that said first function call first, then second function call second. So this is all validated by all peers while the request is being executed across distributed workflow. Yeah, this is also a very nice diagram. Basically saying that if you have several functions and you have some sort of cross-function calls, some cross-function workflow, it means that first function going to be deployed on the first subnet, so several peers will contain the first function. Second function on the second subnet, also they all contain second function, and the third for a third subnet. And you can do, like, with Aqua, you can make them talk any way you want. So like not just as a solid group talking to another solid group. So like you can program like by calling function by peers if you want, or you can say I want to like go from first subnet from peer 1 on first subnet to go to all peers on subnet 2 and execute function, ask them for consensus or something like that. So we can program it all with Aqua. That's pretty nice. The second thing is that we have is a compute marketplace. It's on-chain. It's kind of similar to what Filecoin has for storage. Its providers offers deals, effectors, pricing, payments in stablecoin, and also token rewards for providing capacity, even if it's not being purchased by customers yet, like Filecoin has as well. And token rewards for shared resources, like because some peers, they relay requests to other peers, and you need to incentivize this relay work that they do. Yeah, some picture about compute marketplace. So offers peer, like basically offers specifying, like providers specify how many compute units they have, how they price it, and they enter to deals with customers and set up the price, collateral, stuff like that. So it's pretty simple. And also some more stuff on verifiability is the way payments work is we have several types of proofs. We have this proof of processing that basically proof of Aqua execution, and it's probabilistic and verified on-chain. I'll have a slide on it. We have proof capacity, which is proving that I connected some amount of servers, some amount of compute capacity to a network, and I keep serving it. It's based on proof of work, also verified on-chain. And then WASM proofs that will be included in proof of processing, but not yet. They are TBD because it's not very clear. So proof processing is basically probabilistic payments. So like every node serves user requests. So particles are coming to every node, and there is a target hash set up on chain and target difficulty set up on chain. So they hash all the particles, and at some point they sort of mine particles that come in from users. So one of them, like let's say 1 million of particles, is like winning particle, so it has the right hash. So this particle can be submitted on chain to withdraw the reward for like million of particles. So that's the kind of how probabilism is set. So all the nodes that participate on compute marketplace, while they're serving real requests from users, while they're serving particles, they also check in their hashes. So if they win, they can withdraw. And the amount they withdraw, also like it's It will be not yet accounted in gas. There are several types of gas. There's like a WASM gas for WASM execution. There is Aqua gas for Aqua instructions. There is a factor, basically charging for a factor. It's all three separate gas accounting systems. And they basically priced in deals on chain. So whenever I submit golden particle on chain, I can, the right part of payment can be calculated from it. And the other thing is, we initially wanted to implement this system as like, we had several ways to implement it. We wanted to validate particles on chain with WASM because we have this Aqua VM in WASM. So we tried to do it on FVM to run this WASM validation on chain, but like WASM actor is not ready yet. So we switched to so two other options we had, do it in IPC or do it in ZK. IPC also, like the roadmap, it's kind of close to the IPC launch and audit is close to the date when we want to launch our stuff. So for now, we sort of almost done the solution with ZK. So we're probably going to go with this solution for the launch, but we're still looking at IPC for the scale because like with ZK, what we do is we basically do the ZK proof of golden particle. So we submit ZK proof on chain and we can validate it even if in FEVM, so in Solidity. It's relatively cheap, so it's fine. It works, we can do it on L1. But with L1, usage grows, fees, transactions fee gonna be more expensive. So it's at some point we'll need to switch to IPC anyway. That's the way we see this. Similar thing with proof capacity. Proof capacity is a proof of work based on RandomX. Also, we had option to validate RandomX solution on chain in WASM. It's turned out too expensive, too slow. In IPC, maybe, but also we like the way basically that only worked for us is native RandomX execution, like when you put it like aside of WASM and EVM. So we also working on ZK proof for it, almost done. Seems like we're gonna also do ZK proofs for RandomX initially. Seems like that's easiest solution. Yeah, so like it works also similarly to how Filecoin storage rewards work. So like there are collateral, there is a commitment in time, and providers have to submit proofs. If they don't submit, they lose something. Yeah, and this is our intended state of the platform in winter. So there's this developer platform off-chain features. Initially, as effectors, we're going to have only curl and IPFS, not yet Filecoin, not yet all other stuff. Just have no time at the moment. Have to like delay it a little bit. Commute marketplace on FVM with ZK proofs. That's the goal. They're going to be DAO, but it's TBD which chain, and yeah, because it's a lot of questions there about bridging tokens. And in the future is bright. There is a lot of things we want to expand to. There is a lot of demand from developers for like languages. If we want other languages, there are like limitations of WASM. So we maybe want to support other runtimes. There are a lot of like demand for data integration because like you run functions on top of data and you want to read from data, you want to write to data. So like databases, even like Web2 storage in databases also like people want to use decentralized code on centralized data, which was surprising initially for us, but this is what we heard. Like trust execution environments, stuff like that, useful for TSS MPC. Some sort of DSLs on top of Aqua to look like step functions, to like simplify this development of step functions. And like marketplace features like liquid staking and so on and so forth. So that's kind of probably several years roadmap. Oops. Oh yeah, that's the last slide. Okay, then that's it. Thank you.